and can do. So I've just shared with you a couple of slides here that I'm going to talk you through. So if you go back to the basics and think about the definition of a digital twin, and it came out very clearly from what Stuart had presented. A digital twin is essentially a virtual replica or a virtual representation of a physical asset, process, or an entity. So essentially what you're looking at is, in the case of examples presented by Stuart, a physical asset which has been captured using technology, and you have a virtual representation. The key here in the definition, if you just simply look at an abstract technical definition, is a bidirectional loop when it comes to a digital twin. So meaning that the physical is connected to the virtual, and the virtual or the representation of the digital representation is connected to the physical. So it's a bidirectional link. Essentially, from the physical, you can draw information about the entities that live in that real world. Use that to give insights and decision making to the users, the end users. And based on those decisions, you can drive some actions in the physical world. So from a technical point of view, the bidirectional connection between the virtual and the physical is very important, so that you can drive better performance and better outcomes from your from the digital twin. So what are some of the elements of a digital twin? As I said previously, there's a digital replica which can be captured for an existing asset nicely by Matterport, brought back into an office, and a nice model created with lots of information and data directly embedded in that digital replica. And then you have the physical entity. So those are the two parts of the twin. When it comes to the digital replica, you need to keep in mind, based on the use case, the virtual representation could be a model, like you saw, a 3D model, but it could as well be a drawing, an image, a video, any file, any data, a point cloud. So the virtual representation is quite broadly defined. Any digital asset that is created either during the use of the asset or during its design, construction, and handover. On the real world side, you can actually have the physical entities can represent the entire asset, as you saw, a school building, perhaps a single family home, but it can as well represent any equipment, any product, site, system, space, or a network of assets. So you can think of a digital twin as a combination of multiple twins to represent maybe a transportation network where a station, a tunnel, and other aspects of that network are represented. But you can as well think about real world entities and processes, so you can capture any design, construction, or asset management process also. So those are the broad elements. There are two aspects that are key as you invest in digital twins: the fidelity of a twin and the frequency of the twin, meaning how accurate and precise is your digital representation. And you saw an excellent example of highly precise and accurate digital model of a school building, for example. But at the same time, you also, because you have your twins bidirectionally connected, you need to ensure that they are updated. So if there was any change in the school building, ideally you would capture that so that the digital replica remains true to the physical representation of the physical asset. So the frequency is basically how real time or daily or periodic the updating of the digital twin is. So those are the elements of a digital twin. So if you break it down a little further, you will notice that a digital twin has a virtual representation, which could be a BIM model or any other type of digital asset that's created. And generally that will be the static data. So depending on whether you're creating a twin for a new project or a new asset or an existing asset, you may have lots of handover information, even for an existing asset that can be brought into the virtual representation. You will also have some dynamic data coming into a digital twin through IoTs, sensors, other asset management systems. And as the asset is used and by the end user, you can get more information through laser scanners, through imagery, through videos, and other kinds of dynamic data that can be fed into the twin. So you really need a lot of data management, established information management processes to store all that data and to, I think I'm getting some, I don't know if you can still see my screen. It just went off for me, but here you will notice that there are a lot of, so there are interfaces that you can also utilize to develop a digital twin. So as an asset goes through its life cycle from design to construction to handover to use, you will get lots of data that should be built into a digital twin. We saw examples of as-built data through sensors, through videos, point clouds, but there are a whole set of other aspects of a digital twin, starting with information management processes, BIM and CDE, that can play a significant role as well. So you saw examples of a twin being used for maybe marketing and other purposes or during the use phase, but you can as well deploy a digital twin on a construction site and gather lots of information on a dashboard such as the one that you see on my screen here. And I know Matt is going to go step by step through the every life cycle stage and explain how digital twins can be produced, can be used, and can also be updated. One aspect that also I want to bring forward is this issue of golden thread or digital thread. Remember, a digital twin is as good as the data and the information it carries. And one of the recent developments of a golden thread or a digital thread makes more sense in the context of a digital twin also, so that the information is carried through and vertically and horizontally integrated in our assets. Some more information for you. We have a paper that RICS has produced on digital twins. You can download that freely from our website, and a few other reports that may be of use to you if you're interested in this topic. So with that, I'm going to hand it back over to Matt.